A very good day to you all, my dear students. I am S.Adebayo. We want to continue with our physics from where we stopped in our last class on the topic called waves. Don't forget to subscribe to this channel and make sure you share. You can subscribe so that you can get the updated form of anything that is being dropped in your class. The description or the learning objective that we shall be discussing on today's class is properties. They are properties of waves. And under this, we shall discuss deflection and refraction of waves. We shall discuss interference, diffraction, propagation of waves. Lastly, we discuss progressive and stationary waves. In a nutshell, let's quickly go to the main business. Reflection and refraction of waves. Whenever wave is traveling, I told you that whenever wave is traveling, we have some basic properties of waves that goes along with the waves. The first one is that the velocity at which the wave is moving. The second one is the frequency of that wave. And the last one is the wavelength of the wave. Basically, most time, the frequency of the wave does not change whenever wave is moving from one obstacle. So whenever a wave is moving, and the wave makes or hits an obstacle on the road. For instance, if a signal is transmitted in Lagos, a wave signal is transmitted in Lagos, and it's supposed to travel from Lagos to Osun. I want to believe from Lagos to Osun, there are rocks, there are rivers on the road. Whenever a wave meets a rock or river or any kind of obstruction on the road, it behaves differently. So whenever wave meets an obstacle, it's either the wave reflects from, that is reflection, or it's either it refracts, or it diffracts, or it interfere or polarize. So that's the reason why we shall be discussing all this phenomenon. Reflection occurs when a wave encounters an obstacle and they are made to propagate in the opposite direction as shown in the diagram below. Whenever any wave meets an obstacle, it's as if you are in a wall. By the time any wave meets, you are in front of a wall wave is propagated and the wave goes and hits the wall. The bouncing back of the wave, because reflection takes place when the wave cannot penetrate the obstacle. It's as if when the wave is propagated and it hit a rock. If the wave cannot enter the rock and come out in the opposite direction, in the other direction, the wave will be bounced back, will be sent back. But the sending back of that wave will now take another route, different from the route the wave was coming from. That phenomenon is called reflection. Reflection is the sending back or bouncing back of waves as a result of meeting an obstacle. And you can see the incident wave in the diagram below. It hit a plane, and look at the reflected wave going another direction. So the incident is that wave that has been propagated. The reflected is the wave after it has hit the obstacle. The wave after hitting the obstacle is the reflected wave. Are we together? Okay. So another thing I want us to know here is that reflection occurs in sound and light waves. And that is the essence of our echo. When you hear the word hello, 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 those echo you hearing is as a result of reflection. Or let me say echo are due to the phenomenon of reflection. Sound, well, that's why you see whenever you are in a big room and that room is not having any materials inside of it, whenever you talk, you hear your word back. Why? Because there's no body, there's no equipment that will absorb your voice. So that's why when you talk, it goes straight to the wall, hit the wall, and it sends it back. The wall sends it back. And that's why you hear it like 2 or 3 times after. That's what we call reflection. But if there are materials like belts, like chairs inside that room, and you talk, you will see that you will not hear it. But why? Because by the time you talk, it will not even reach the wall, because all those materials there will have consumed the voice that you have spoken. Now, refraction. Refraction occurs when the wave is made to travel through media of different densities. Now, What happened in the refraction is that, I said whenever a wave is moving and I use a wall or a rock as an example, if the wave hits the rock or wall, it bounces back, just because the wave is not having enough power or wavelength to enter the wall or rock. If the wave can enter the wall or rock and now goes out and now continue going, it penetrates. That phenomenon is called refraction. So refraction is the changing in the direction of wave as it enters from one medium to another. You can see now that refraction involves two media, because a wave must travel from one media, penetrate the obstacle, and go into another media. So refraction is consisting of two media, and whenever there is a refraction, there will be a change in the speed and direction of wave from from one medium rather to another. So whenever there is refraction, don't forget the direction of wave. Though in reflection, the direction of wave is also changing. In refraction, whenever the dark wave enters the obstacles and goes in another way, there will be a direction of wave changing. At the same time, there is two media involved. At the same time, the speed of the wave also will be changing. That's one thing I want to do. In refraction, the speed of the wave changes. The incident I and the angle of the direction of the incident wave from the front makes the normal at the boundary. The angle, I think this is explained in the diagram we have here. Look at this. Look at this. This is explained here. I think that will show us more about, sorry. I'll have to go back to the slide. Okay. Look at this slide. This is exactly where we have medium one. Then look at this race. This race goes here. This obstacle, it penetrates and goes another way. This is medium two. So this is exactly the angle of the incidence, the angle it makes with the normal. This is the angle of reflection. If it's refraction is somehow, I think I want to look at this. If you have, this is a plane. If this is a plane, if the wave hits this plane, the obstacle, it does not penetrate, it goes back. This is what we call this is reflection. But in refraction, when the wave enter, it hits the obstacle, it penetrates the obstacle, it still goes another way inside the obstacle. This is exactly what we call refraction. So refraction is bouncing back. So refraction or refractive index, there are three formulas I show here to explain the refractive index. There are three formulas I want you to understand here. The first one is that the refraction from medium 1 to medium 2, which called the rate at which the refraction takes place, is called refractive index. That's the rate at which the refraction takes place. So the refraction from medium 1 to medium 2 is actually the speed of the wave in medium 1 over the speed of the wave in medium 2. That's number one. If the wave is moving from a deep water to a shallow water, the refractive index is also the speed in the deep water over the speed in the shallow water. Or if the refraction is taking place from a particular medium to another, the refractive index is the sine of angle of incidence. Don't forget, angle of incidence is the angle the refract, if this is the ray, if this is a normal, the angle the reflect the incidence made with the normal. And the angle of refraction is the angle the refraction make with the normal at two. So the refractive index is the sine I over sine R, which is the sine of angle of incidence over the sine of angle of refraction. Okay. And then on next slide, we want to talk about interference. Interference is phenomenon of two or more waves of the same frequency, amplitude, and wavelength traveling in opposite direction. Sorry, in same direction. And they are superimposed or overlap. When two waves of same frequency, amplitude, and wavelength traveling in the same direction are set to overlap, or when they overlap, what we have interference. How many of you have really experienced whenever you are tuning your radio? When you tune your radio, maybe you are tuning Crown FM, or you want to tune a particular radio, let's say you want to get Orisun FM, and you discover that at the frequency of Orisun FM, there is Crown FM just film. Or let me say you are listening to a particular radio. It happens when we have AM in those days. When you are listening to this radio, you just hear the voice or the program of another radio just within like 2 or 3 seconds. In Yoruba land, we call it our station Ojapo or something. There is still kind of station here Ojapo that is overlapping of the waves. We are hearing station A, but when you are listening to station A, station B, just like 3 or 4 seconds from surfaced, you hear it, and like 3 or 4 seconds it's go. That point in time we call it interference. That is overlapping or superimposition of one wave over the other. Station here on the frequency overlap. So when we have overlapping, and what happened? Why do you have interference? When the 2 or more waves that have the same frequency, the same amplitude and wavelength, and they travel in the same direction, are overlap or they are superimposed. We have 2 types of interference. We have constructive interference and we have destructive interference. For constructive interference, the 2 waves are superimposed in the same phase. Crest or cross. I want you to look at your diagrams in your textbooks to get this clearer picture of whenever we have a constructive interference and destructive interference. Diffraction, that's another property. You know, I've talked about reflection, bouncing back of wave when it is obstacle. I've talked about refraction, that is when the wave penetrates the obstacle and it enters another media. We have talked about interference, the superimposition or the overlapping of waves when they have the same amplitude, frequency, and they move in the same direction. And next one now is diffraction. Now let me explain diffraction. Whenever a wave meets an obstacle, is either it reflects when it bounces back, or it refracts when it enters the obstacle, or it can interfere when it overlap, or it can diffract. What do we call diffraction? Diffract is that the wave do not enter, it do not also bounce back, it now stay around the obstacle. The wave is not penetrating. When the wave is hitting an obstacle, it's not penetrating, it's not bouncing back. The wave now stay around the obstacle. It's spread around the obstacles. That particular phenomenon is called diffraction of wave. So that's why diffraction is the bending or spreading of waves around corners when the traveling wave encounters obstacles with the whole aperture. It's mainly happen when we have a small holes around the obstacle in which the wave wants to pass through. So depending on the wave, depend on the size of the aperture. If the width of the aperture is smaller than the wavelength of the waves, so the wave will bend and spread out more. Let me explain this very well. Let's say we have a gutter. A gutter have a small opening. Let's say there is a gutter that leads from your house to another house. And there is much more water when there is rain. When it's raining, there's much of water that passes through that water. Very much erosion, big water coming when there is rain coming up. And the road that leads at your gutter to the second or to the outside that will convey the water, the hole is smaller, like a small pipe that will convey the water outside your house to maybe to the street or to the gutter of the main street. So that means when the rain is on, the water will be so plenty and the water will not be able to pass through the small opening. There will be much inflow of water, but when the water gets to the outlet of the gutter, there is a small hole that will take, or the water will pass through to go outside. What will happen is that when the water is now gushing, when the water now gets to that place that the water is going to be supposed to be moving out, there will now be much more water roaming around that outlet of the water of the gutter, because not all of the water that are coming down can go out at the same time. So the water will now be spreading around and be going inside gradually. That's exactly what we call diffraction. The spreading around of the wave because of the opening. When the opening is very small compared to the wavelength of the wave, the wave will then spread around the opening. And the example of this is shown around in the diagram that you can see in the page displayed. Polarization of waves is a particular paramount or a kind of difference thing, or a kind of thing that we can use to differentiate a transverse wave from a longitudinal wave. Just because polarization is only transverse waves that do polarize. Transverse wave polarize, longitudinal wave do not polarize. Don't forget, transverse waves are rivals. I shorten them as all these rivals. The radio, infrared, all these electromagnetic waves are all transverse. And the polarization takes place in transverse waves. All these sound wave, for example, is a longitudinal wave. It does not polarize. So a wave is said to plane polarize if it is constrained to vibrate in one plane. Whenever any wave vibrates in one plane, it is said to polarize. An example of that is what I have put there. A polarized light can be produced using a polarizer, and that is a tourmaline, crystal, quartz, or polaroid. A polarizer will only allow light to vibrate in only one direction, so any other vibration will be absorbed. So any other wave that is made to vibrate in only one direction is said to be a polarized wave. And the example of that, or the diagram, is what you can see in the figure display. You can see the polarized wave, the star. You can see the polarized wave here. You can see the unpolarized wave here, and you can see the polarized wave traveling in one direction. You can see that's it. You can see this one traveling in different direction. This one polarized wave in this one, and this one is polarized wave, which is traveling in one plane. It's not that it's traveling in different planes. No, so another means of polarizing light wave is by reflection. The light is incident at another angle of 57 degrees if you can polarize that on the polished surface of a glass tube. Now, I want us to understand this, that a light can be polarized because a light is a transverse wave. And we can polarize, we can make light to reflect in only one direction. And a practical application of polarized wave, before I go there, there's one thing we call blister angle. The blister angle is the angle of polarization of light, which is 57 degrees. Light can polarize when you try to make it reflect at an angle of 57 degrees to that plate, to the glass plate. So this angle is called the Bristol angle. Now, the practical application of Polaroid, a particular material that polarizes, is a Polaroid. So all these Polaroid are used as sunglasses. Sunglasses, you must have seen sunglasses, all these black shade glasses that are used to control or reduce the intensity of sunlight that will come into the contact with the hair. So Polaroid can also be used to eliminate light glare from window pane. You see some of the windows or the tinted glasses of most of the cars, they are made of Polaroids. Those are things, the kind of materials that polarize, so that it can made to constrain to vibrate in only one direction. So Polaroids can say from window panes, glass door, polished tabletop. Also, how chemical substance polarize light has also been used in SWOT analysis. Now, progressive or stationary waves. I said this before. A progressive wave and stationary wave. I made examples and differences between these in the last class. But I want us to just quickly look at it. A progressive wave is a wave that travels and continues to spread out from the source of the disturbance. While a standing, don't forget, a progressive is also called a traveling wave. A progressive wave is a traveling wave. That's why I said a progressive wave is a wave that travels and continues to spread out from the source of the disturbance. Why a standing or stationary wave is a wave that is produced when two waves of the same frequency and amplitude are superimposed or overlap. So the superposition of the two waves of the same frequency and amplitude are exactly out of phase leads to the formation of region of zero resultant in substance as shown in the diagram below. Now we want to talk about standing wave now. And we said standing or stationary wave is a wave that is produced when two waves of the same frequency amplitude overlap. Let's look at them. Let's look at the diagram. Look at the diagram here. Look at this wave. Wave A. Look at the wave A. Look at this wave B. When you put the two together, this is what you have. So when we now look at their resultant, when we, as if you add the two of them together, we have this. So this resultant wave is what we call standing wave. When we try to overlap two waves to get one single wave, a superimposition of wave. So if the two waves have different frequency, this is, look at this now, superposition of two waves of the same frequency and wavelength traveling in the same direction. Now, superposition of two waves with the same frequency traveling in the same direction are out of phase. When we have a look at this one, this is out of phase, this is of the same phase. Look at this, and we have this. So this is exactly what we call standing wave, when the two waves overlap. This is standing wave, and this is when we have the same direction and they are out of phase. So we just neutralize each other. So this is exactly what we call standing wave. Okay, let's look at the next slide and let's see what we have there. A stationary wave are obtained as a result of combination of superposition of an incident wave and reflected wave, which is of the same frequency wavelength. I think we have discussed this before. And we are wanted to just look at them and try to read them up. You can read them up. Standing wave, you can see. Okay, let's see what we have next in our slide then. Okay, I think the next is evaluation. Now, I want you to try to look at the stationary waves, the diagrams, your textbooks explain this more and more. The stationary waves and the difference between stationary wave and progressive or traveling waves. So that then we now look at these evaluation questions to really ascertain if you have really learned one or two things in this course of study or not. On this note, I want to drop the curtains and I want to intimate you that you should try to subscribe to this channel so that you can get update of whatever that is being dropped here. Thank you very much and thanks for your audience. Good day to you all.